start with two assertions. The first assertion is this, that architecture, when we talk about software architecture, does not live alone. It doesn't live in a silo, but rather must be aligned with other aspects of the business and technical environment. We call these the intersections of architecture. And specifically, because there's multiple intersections, we call these architectural nexus, a very weird word. It's got a little caret on the top of it, but what it means is multiple intersections of intersections. That's the first assertion I'm going to make. So when we talk about this kind of alignment, we do everything from looking at those star rating charts in our first book, The Fundamentals of Software Architecture. Many of you might be familiar with Neil Ford and I's star ratings that we did. And these star ratings allowed us to say which architectures would be better suited for scalability. And we can look at the stars and say, well, that architecture is only 1 star. This one's 4. That one would be better. I don't know how much better, but characteristically, it's a little better. So we apply all those principles, and our architecture still doesn't work. We go to our second book, Software Architecture, the Hard Parts, where we really dive into how to make those really hard decisions in distributed architectures. And we apply all of those kind of modern trade-off analyses, and our architecture still doesn't work. What's missing? We've done all the right stuff. We read your books. We've seen your videos. It's still not working. It's because the architecture is likely not aligned. When I say aligned first of all with implementation. Is it implemented the way the architecture was specified? Maybe it's infrastructure. The architecture and the code scales, but does the infrastructure that it's put on scale? That will impact those kind of operational characteristics. Data topologies, which we kind of looked and touched on a little bit yesterday in the data talk, can really influence whether an architecture works or not. Even engineering practices, those processes and procedures, the way we actually develop, test, and release code can impact an architecture and impact the success of that architecture, and vice versa. As a matter of fact, following that, team topologies can significantly impact an architecture as well. And these can go drilling down all the way into the team topologies like streamlined teams or complex subsystem teams or enabling teams, or even be at a higher level of just the way the teams are partitioned, either technically or domain partitioned. And if that is not aligned with the architecture, teams will really struggle to even make the simplest of changes in that architecture. Also, things like systems integration, integrating with other third-party applications, systems, services will also impact the success of that architecture. These all need to be aligned, including the business environment, the enterprise, and also alignment with the Gen AI kind of ecosystem. All of these are factors that have to be aligned in order for architecture to work. Now, what we're going to focus on specifically in this particular session here is probably one of the most important intersections for all of you in this room, unless you're a dev manager or infrastructure folks, then in that case, we should probably talk about the second one. But for most of us, this is where we immediately see a misalignment, things not working. And what I'm going to show you in this session is how that misalignment can occur. But more importantly, how do we fix and ensure that the way we implement our systems matches the architecture of that system, the structure of that system? Now, in order to do this, there's another concept, another assertion I want to make. And that is, in order for architecture to work, it must be measured and governed. If we don't take measurements of observability in our architectures, we have no idea whether it's aligned. And we call that architecture as code. Okay, so what we're going to do is take this concept, which I'm going to describe for you, architecture as code. And we're going to see how to actually leverage that to be able to ensure this alignment with architecture and the way it's implemented. Now, I'm going to be using ChatGPT-4 for all of my examples, but it's only illustrative. You can use any kind of LLM for what I'm going to show you in this session. Okay, so when we assure that alignment, we can also do one other thing, which is going to be really cool that I'm going to show you in this session. Architecture as code. What in the world does that mean? We know infrastructure as code, policy as code, and we have all these X, whatever, as code. What in the world is architecture as code? What architecture as code? Oh, wait, I almost missed the one most of you probably know about. Diagrams as code. Wasn't that cool? We could take any architecture diagram, and in most tools, we can use Archimate, C4 model, PlantUML, Draw.io. We can actually take these diagrams and export that diagram as code, and usually in an XML type of format. You know what the problem is, though? If I give my development team an architecture diagram, that development team can see that diagram. It's like, yeah, Mark, I get what you're doing with that. Thank you. Okay, we got it. We have an understanding. Now let me go and code. Yeah, we've completely forgot about that architecture diagram because we use it to gain a conceptual idea of what we're supposed to be doing as developers. Diagrams as code is not enforceable. Great, so I can put it in a machine-readable language, but that's kind of, sort of somewhat useless, at least today, somewhat useless. What I'm going to show you is how to write code through a pseudo language called ADL, Architecture Definition Language, to be able to describe an architecture through executable source code. Oh, you could still use a diagram, but now I'm able to describe my architecture for you, and I can execute that code. And now I can enforce that code. I can ensure that alignment. So this is the other exciting thing I'm going to show you, which is on the screen now, which is I could take all of the code we're going to be writing, and that actually can form documentation. Let me back up. Executable documentation describing my architecture. That is cool stuff. That's what's called architecture as code. Okay, so that's our journey in the next 50 minutes. So what do we do as architects? Well, as architects, we draw diagrams. This is my view and my architecture of the current system that we're going to write, or maybe it's even an existing system. And actually, that's a really important point to make here. All the stuff I'm talking about in this session is not just for new systems or products. It's for existing systems or products as well. Is your existing systems architecture aligned with the way it's implemented? So here's what an architect does. What does a developer do? Well, they take this diagram and they write source code. And all too often, these two artifacts become misaligned. And I'm going to show you examples of those. And that will not work. Oh, yes. So now, second session that some of you have seen, and you've probably identified my favorite animation of all. It's the dumpster fire. It's the little flame that sparks up because nothing seems to work in our industry. Yes. Well, let's talk about two kinds of alignment, structural and constraints alignment. I want to start with structural. Now, what do I mean when I say architecture? How do we see the structure? Architecture is the structure of a system. But how do I see that in the source code? What do you really mean? Well, take this floor plan right here of this building. Well, if we look at it, it's got various rooms and stuff. And each of those rooms have a particular purpose. We eat and make food in a kitchen. We sleep in the bedrooms, and we shower in the bathrooms. I mean, each of these have a different purpose. And depending on the types of walls we have in this house or this flat or apartment, I can move these rooms around and stuff, but they all serve a specific purpose. We can think of these rooms in this particular floor of this house as the building blocks of that house. I mean, if you think about it, what is a house? Or I'll say a house apartment. Let's take an apartment. Well, if you removed everything from it, walls and everything, it's just a shell. Yeah, it's the rooms in it that form the building blocks. By the same token, the things a system does, whether it's managing inventory or returns and credits, fulfilling an order, these also are the building blocks of our systems and products. And as a matter of fact, we put these building blocks together in structure to form that monolithic application or even combine them to make services. The bottom line of this part here is that logical components, building blocks of a system, the things the system does, really are the building blocks of a software system. It forms the architecture. So now we can start to see this vague and mysterious connection between architecture and implementation. When I spend all my day drawing lines and boxes, what does that even mean when we come to implementation? That's what it means. So let me give you 2 examples, and then we'll see how we can get misaligned and how to realign this. So basically, when I construct all these logical components, when I think of my, quote, architecture, usually it is manifested through the directory structure or namespace, how we structure our code. You know, this is pretty interesting because the higher level nodes represent the domain and subdomains of your system. If you think about it, and I know many of you probably undergo domain-driven design, informally or through the formal DDD process, we identify domains, we identify subdomains within there, we identify bounded contexts and consumer-supplier collaboration patterns, communication between those, ACLs. So we do all that work. Where is it? If you looked at your source code, would you see it? So the structure of your source code represents the structure of that system, the architecture. That's how they equate. So the higher level nodes of your namespace or directory represent those domains and subdomains. And then the leaf nodes represent those building blocks, those architectural components. Well, we as architects are concerned about these components, these building blocks, how they interrelate, how big they are, how easy they are to maintain, do they scale? So consequently, let me actually just solidify this. Let's focus on payment. So I, as an architect, say, well, we have to do payment processing. And there's probably a lot of code for payment processing. I don't know how that's going to be implemented, but I do know it is part of the architecture. It's a part of a logical component. So I define, well, what do you do as a developer? You get a user card or a user story that you have to charge a credit card. So I create creditcard.java and write a method called charge card. Well, if I write that code, I physically, as a developer, have to put it somewhere, don't I? I mean, it has to reside in a namespace or has to reside in a package structure or directory. And so consequently, why don't I put it in a payment directory or namespace? That makes sense because it has to do with payment processing. Alipay, PayPal, maybe any other kind of payments, inter-service transfer. Any of these kind of payment types would all, as classes, go under payment. But we know now that that directory represents that logical building block, that component in the architecture. And consequently, what it means is this class file implements that logical component. Okay, so there's our definitions. All right. Now, let's have some fun. So this is a architectural kata, a use case called Sysops Squad. This is one of the use cases that we introduced in our book, Architecture, the Hard Parts. It's a trouble ticket system. Basically, what happens is a customer buys and purchases some sort of product from us, and they then register with the site. And they can also then kind of, update profiles and stuff. But then if they have a problem with the electronic device that they purchased from us, home entertainment system, a stereo, a computer, whatever, they can go onto the website and create a ticket. So they create a ticket, and then the ticket tries to assign it to some sort of expert, field expert, that's available somewhere in the field. We found somebody. So once we found that expert, then we assign that expert to that ticket. The customer gets notified that the expert is on their way. Then the ticket's uploaded to the expert's mobile device. The expert goes to the home or office, fixes the problem, marks the ticket as complete, and we send a survey to the customer. The customer hopefully fills out that survey, and we receive it. There we go. That's how this system works. Let's do this. Let's create an architecture for this. Let's say that this is a new system. How should it work? Well, first of all, I kind of see 3 domains. There's the whole ticketing portion. There's the customer where they register and kind of stuff like that, update their profile. And we have surveys. So I define 3 different domains. Well, within ticketing, what can we do? Well, there's a whole bunch of processing in creating a ticket. That's not a class file. It's an architectural component. It's a building block. That may be 1 class file. It may be 100. I don't know. But also then, I have a ticket queue. Sometimes there's no experts available, so I have to kind of hold that ticket so that it continues to get searched for an expert. Okay, well then, we've got this whole assignment process. Well, I'm going to create a subdomain called assignment. And with an assignment, well, I assign the ticket to an expert. I have to route it to the expert, and then also notify the customer. And you can see the interactions of these components. The only other thing that happens in ticketing is that the expert can complete a ticket. We do the same thing with customer, being able to register and update their profile, and surveys, sending, receiving a survey, and maintaining the various templates we send out for the various products. Customers interact with these various components and domains, and the field expert gets routed tickets and completes them. That, folks, is an architecture in 90 seconds. There we go. This is what an architect does. Instead of just saying, well, we're just going to start coding. No, we should kind of have an idea of this architecture. Okay. Now, based on our prior definitions, what should the structure of the code look like? This is what it should look like. Notice ticketing domain. Well, I've got Sysops, which is the name of the application. I expect to have a directory or a namespace called ticketing. There's customer and there's survey. That's good. Do you see? I can now go to my code base and I can refer to those domains, subdomains, and also components. There's all the assignment components, the 3 of those, the leaf nodes. Also, customer, ticketing, assignment, there's customer, and finally, survey. Cool. This is kind of enlightening just right here. Because as a developer, do you know what this means? Every time you create a new namespace, every time you create a new directory in your GitHub repo, you are changing the architecture. You are creating new domains, subdomains, and components. So, well, good. Excellent. All is right with the world, except this is what happens after production release. This is the directory the developers came up with. And as a matter of fact, if we kind of look at it, well, thanks for your, let us code. Yeah, we know what we're doing. Let us code. That's what they came up with. Where's ticket assignment? Because it's easy to see in the diagram of the architecture that that's a building block. That's a whole thing the system does. Where in this code base do you see assignment? It's there. I don't know. I guess I'm going to have to do some searches or something, or go ask some people. Hey, wait a minute. What about customer registration? I mean, I see the word subscriber, but is that where it is? I don't know. All of a sudden, I've got some questions about where to find stuff. Also, what's this mobile connection thing? I mean, that's sitting there as a subdomain level. I don't have that subdomain in my architecture. And I see send survey, but I need to maintain the code for receive survey. I don't know where it is. Do you see? The point is, This is the architecture the developers created. If we reverse engineer that directory structure and namespaces, that's what the architecture looks like. Interesting, isn't it? Because that is a lot different than the architecture I created. Scary, isn't it? Yes. How many times have you been given an architecture diagram, a C4 model, something in Dry-O or Excalidraw, which is one of my favorites, and you're like, okay, yep, got it. And you just start coding. Yeah. There's no association there other than a vision, which clearly wasn't followed. So why? Who cares? Mark, yeah, I mean, that's nice vision. Yeah, we got it, but that's what was created. If we look at these two things, tell me, that'll be the left and that'll be the right. Which one of these as a developer is much easier to maintain? Left. How about test? Yeah. How about deployment in terms of risk and breaking something? Yeah, this is why we do architecture, because those things are important to us. Which of these do you think is probably at the product more reliable? Yeah, this doesn't take much to say. The one Mark created, good luck changing this thing. And as we change it, we're going to break stuff. That's overall reliability. Which one of these do you think would be easier to adapt to various changes in platforms or upgrades to Java or yet another, no, I should say a .NET upgrade or yet another Java upgrade? How about extending this architecture? Now, which one would be easier to add new functionality like reporting or something? And finally, what if this were a monolith and you wanted to break it apart? Which one? That's why this alignment matters, everybody. That's why architecture matters. It's the structure of the system. Oh, we are in Hall A right now. What are we trusting? That this isn't that nightclub in South America, I believe it was, that the roof came tumbling down. Yeah, we're trusting that the structure of this building is sound and will be sound at least for the next 36 minutes. Yeah. After that, you know what? We're going to be out of here and say, oh, tough luck, fella. Yeah. But at least for now, we care. How do we know that this structure is sound? Because some real architect, as Venkat said this morning, are you an architect or a real architect? Some real architects actually drew up plans for this thing based on loads, based on weather, based on heat conditions, cool conditions, the weight of people on the stairs. This was all planned. What if it wasn't followed? I'm going to need to get out of the room here somehow because now I'm getting a little nervous. Yeah, this matters. Okay, so now let's see how to fix this. And that is called architecture as code. This really cool concept Neil and I came up with about close to almost 5 months ago now. This is the material for our next book that we're currently working on, titled Architecture as Code, Making Architecture Work. So you're seeing firsthand some of the material that we're currently writing on. So this is pretty cool new stuff. But it's a concept that we are actually practicing at our clients now and finding a lot of cool success. So what we're going to do is take something called an ADL, an Architecture Definition Language. Now, Neil and I created our own. You can use it. You can create one of your own. Doesn't matter. It's a pseudo language that describes my architecture. And consequently, what we're going to do is feed that into ChatGPT or some sort of LLM, Gen AI. And we can generate ArcUnit code for Java. We can generate TSArc code, which validates executable code, which is going to validate our architecture in JavaScript. For .NET, I can use NetArcTest or ArcUnit.net. And finally, for Python, I can use PyTestArc. Now, I could just circumvent this whole process here, and I could just go and write this code. And that's what I always used to do. This code is fantastic for governing all of the things I'm going to show you in the structure of the code, because it's executable. But the problem is this. In order to see my architecture, to understand it as documentation, I would have to read source code. Most of us can do that, but some stakeholders might want to know our architecture and might not be able to read that code. If I change my architecture, which is what we're going to do in a little bit, what do I need to do? Oh, I need to go in and change all the source code. I'm going to show you an easier way to do this. So we had identified how many? 3 domains in our architecture, didn't we? How do I know if that's really in the code base? Well, I can write an ADL, an architecture definition language, that looks like this. This is just pseudocode. A description defining domains. Define the system, Sysops squad, as Sysops. Now, the as piece points to the directory or namespace. Define the domain ticketing as ticketing. Define customer, and define a domain as survey. And I'm going to assert that all classes in this entire system are contained within subdomains within those specific domains. If any code sits outside of those 3, fail. And as a matter of fact, this is the corresponding understanding of the directory. Sysops, ticketing, customer, survey, this is pointing to those higher level nodes. Now, what do? I take this ADL, I write a prompt. Now I'm going to be using ChatGPT 4 here, but I write a prompt and say, using this pseudocode, generate an ArcUnit test in Java. Or I can say, using this pseudocode, generate a PyTest arc in Python, or an ArcUnit net test in C#. I can do any one of these. And I do that, and this is what ChatGPT tells me. Oh, I see. So you're trying to assert this. This is just plain text. And this is not a formal language. This is just a kind of a pseudocode. So it says, oh, I see. So no classes can exist outside of any of those packages or namespaces. And it generates this ArcUnit code right here, of which we can see the rule here is perfect. It's executable. Now, we have done, well, I'll go as far as to say, I want to say thousands, but many hundreds of these tests. And we're getting about a 90 to 95% thumbs up hit rate on it generating the actual correct ArcUnit, ArcUnit net, or PyTest arc code. This is pretty cool. I can execute that now and have it fail or succeed. For those of you in .NET, here's the corresponding ArcUnit net. All I did was change the prompt to say, oh, instead, generate this in ArcUnit net using C#. And there we go. There's our test. This is pretty cool. If any developer created another directory, higher level directory, this thing fails. This is pretty cool. What about those details of the domain? Oh, what about ticketing? Can I describe that part of the architecture? Sure. Here's my ticketing domain, Sysops. So I'm going to define my domain ticketing. What's in ticketing? I have 3 components and a subdomain, don't I? So I can say define component, that's an architecture component, ticket creation, a logical name as creation, ticket completion, I can define ticket queue, and also subdomain assignment. And I can assert here that classes are only contained within components and subdomains within ticketing. As a matter of fact, that's pretty cool stuff. I will make these slides available, by the way, because I know some of you are like, this podium's in the way. I can't see that. So, yes, I will. Matter of fact, I'll give all of you a link. I'll need to upload it this afternoon, but I'll give all of you a link before the session ends. But what I've just described, think of what we're doing here. Is this readable to anybody? It's readable to everybody. It's not a formal language. Now, we have an ADL spec because we'd like to be consistent. But the point is, anyone can read this and see this. If I change it, I change the ADL. That's my documentation. Think about this, what we're doing. That's architecture documentation. What's ticketing all about? Right there. That's what it is. And now I go and generate the code. And of course, we've got all the associations. This is what the directory structure should look like, or the namespaces in .NET. And so consequently now, I can run this through ChatGPT or Gemini or any other Gen AI tool, and it says, oh, wait a minute. Classes under domain ticketing must reside in either creation, ticket queue, or completion, or somewhere in assignment. Oh, that's perfect. If a developer adds any additional directory, that's a new component, fail the test. This is pretty cool. Now, we will fail these tests. I'll show you in a little bit. But I generate this, and we get our corresponding arc rule in Java, in Arc. I can execute this now. There's the C# version. I wanted to be fair because I know this isn't a Java conference, but I didn't have time to do the Python, the JavaScript. But you know what? You can do that, actually, because all this stuff is fortunately free. Okay. Well, we could define other things as well as our subdomain. In other words, I can say, well, what's assignment all about? And I could do this same thing. Notice what we're doing is utilizing this as, if this is a document, this resides in your Git repo, just like source code, or it can sit within an architecture decision record. This is just documentation, but executable documentation. So now I assert that all classes have to reside in one of these components within assignment and do the exact same thing. So by doing this kind of and no, I don't want to call it enforcement, validation is a much better word. And let me show you that piece in a little bit. Okay, so we can correspondingly see, I can actually generate the code. Like I said, we've had much, and this is weird, I don't understand why, we've had much better success in this, in generating the actual code to basically, in ArcUnit, it is about 95+% of the time. There's no changes to this code whatsoever. As a matter of fact, it's smart enough to actually take the description tag and make that the actual method name. All right, that is just really cool. I did not know how that happens. C#, about 75-80% success rate. There's some nuances in C# generating NetArc test and ArcUnit netcode that ChatGPT at least just does not get. It's like, I don't know what to put in here, so it just starts putting some class. It's like, oh gosh. So there are a few tweaks to put there. Well, I want to show you just one more. So that's good as structure. It's the other part of structure. Well, it's how things are coupled. I mean, I want to manage who's talking to whom. Because if we all start talking to one another, this thing just won't be maintainable, testable, deployable, scalable. I mean, this is going to be horrible. Can I do that as well? Absolutely. Because now with the survey, I can now say define dependencies, define domain survey, define component send, receive, and survey templates. Those are the components we have. Now, watch this. I can add as many assertions as I want to. Assert that send has no dependency on receive. Assert that receive has no dependency on send. And assert that templates has no dependency on send or receive. Those are my constraints. That's pretty cool. And as a matter of fact, if I now put this through a prompt, it says, oh, let me build you a table of what's allowed to talk to what. And correspondingly, now it generated a method for every one of those assertions. This is really cool. As a matter of fact, this is how I, as an architect, am currently leveraging AI as an assistant. Now, again, could I write this code? Yeah, I can go directly and write this code. But think of what I'm missing here. What I'm missing is that documentation. You could use code as documentation, but I'll tell you what, I'd rather use the ADL. So everybody can read it, and it's a lot easier to maintain. Yeah. Okay. So now, let me show you an interesting aspect of this. Because let's go back to the real world, though. That's pretty cool. But what happens in the real world? I love real world talks. Well, So the development team gets a new ticket. Add functionality for customers to sign into the system. What's our current directory or namespace look like? Right there, customer registration profile. That's it. We have two. So now I know we have a domain, customer, two components, registration profile. And that's the logical architecture. I could diagram it. I've got the ADL and the code. All this is running perfectly fine. What did the developers do? Yeah, watch this. Are you ready? Well, clearly I need sign-in service. So what did they do? They add a directory, sign-in. Yeah, I would do that. Consequently, though, what happens? I just changed the architecture. I just changed the structure of the system. And guess what fails? The ADL, but more importantly, and this is the key, the executable source code that runs upon every build or every release just failed. That's cool. Now, I'm not at all recommending that you use this or architects use this as a stick to beat developers over the head with, because this developer here did exactly the right thing. But here's the key. Why don't systems work? Because we keep adding functionality. And every time we add functionality, we start coupling things together. We didn't intend on coupling together. Oh, we start accessing tables that I never had to access before. And the whole system just start getting this big, ugly, coupled, unstructured mess. So rather, this test will fail, by the way. Here, it's just magic. How often does your architect talk to you or get involved in your system? Never. They're not around. How often do architects talk to developers? Never. They're not around. This is another reason why systems don't work. Because we need a tighter collaboration between architects and development teams. Because architecture always evolves. It always evolves because we're constantly changing and adding new features to our systems. Consequently, look what just happened. I had an executable test fail. This is now a placeholder. Now, I'm not going to hold up that build or that deploy. That would be a little draconian. Unless you're building a medical device or a missile, then hold up the build, please. But if you're building a business application, let it go. But this is a placeholder now. I get alerted as an architect, or the developer says, "Oh, I gotta fix this test." So consequently, either the tech lead or the developer now says, "Oh, duh, I just changed the architecture." So consequently, look what I just did. I updated the EL, and now what do? I regenerate the test, and now it all passes. I now have real, accurate architecture documentation. Maybe I didn't update the diagram because I didn't have time. Okay. But consequently, I do have documentation. That's the ADL. This, everyone, is this concept of architecture as code. Because we have it for security, we have it for infrastructure, we now have it for architecture as well. I mean, how cool is that? So this is how it can be used in the real world to keep a collaborative relationship between developers and architects. The architect's now always involved because they may say, the architect may say, "Oh, tell you what, let's talk about this because, that functionality might be better in this component over here. Instead of creating a new component, why don't we take those classes and move them in this directory so that we still have the same component? Because this is getting a little large, or I'm worried about the coupling, or this one has to scale, or this has to be fault tolerant. So I want to make this a little smaller." And now we can have those conversations. This is really cool. One of the things I'm working on, and I've had some good success with, is actually reverse engineering a directory or namespace to either ADL or an architecture diagram. That's pretty cool too, because then we can see, well, gee, I'm currently working on a very large banking application. I wonder what our architecture looks like. Did you ever wonder that? What's our architecture look like? And if you're in a distributed architecture, I can tell what each service looks like. How maintainable is it? boy, if you reverse engineer that and you just draw this out in Draw.io or Excalidraw or whatever, you might need 2 days of therapy to recover from that architecture diagram. It's like, that's why we have trouble testing. Yes, it's really enlightening to actually reverse engineer this and actually see what kind of architecture we actually have. So these are techniques for now being able to actually align the implementation with the structure of the code. I want you to all just for 1 second, just look around at the sides and the back of the roof of this building. This is a perfect analogy. We have trust that this thing's not going to come crashing down. Now, yeah, we hope. It is a science center, by the way. So I've got some faith right there. Okay. Oh boy, yes. Not performing arts. I would not. No, just kidding. That wasn't fair. Probably true, but it wasn't fair. No. But now I want you to do the exact same exercise. Just spend 10 seconds thinking about the current system or product you are working on right exactly now. Just think about that system, whatever it is, a product, website, mobile device. How sound is it? What's the structure? Is it going to fall apart? The next user that signs in was the one user that broke the straw on the camel's back, had caused that thing to crash to the ground. Ouch. Isn't it nice to actually know that ahead of time? Yes. Well, let me actually finish up by talking about a different kind of alignment. And this is an interesting one because we talked about structure. And now all of us, or all of you, now understand, wait a minute, now I can start to see how architecture and implementation kind of do relate. I mean, these are important intersections. Maybe this is some of the struggles we're having as a team to maintainability. I'm sorry, but you keep giving me these requests. I don't understand our code base. I mean, who on the team understands the entire code base, knows exactly where every code is? No, not me. Of course not. It's too big. But if there's a structure to it, that's the architecture, internal logical architecture. But let's talk about a different one. So look at this case study right here. Here's our requirement. So we have a very tight budget and also a tight time frame for this new product. Said no one ever. But we're expecting a constant amount of change to the underlying database structures. And when those happen, we need to move really fast to get those to our customers. That is our problem statement. Let's put on our architect hat. Okay, so here's the star ratings I talked about at the beginning of the session, our famous star rating chart from our fundamentals book. Well, let's leverage it to select an architecture, because what's important to us? Well, tight time frame and budget means that we're going to be focusing on cost and simplicity. And so if we look at these, 1 star means not very good. 5 stars means, yeah, that's kind of the architecture you want. We can start to see, oh, layered is good. Modular monolith is good. Microkernel's good. And, well, maybe service-based, but it's a distributed architecture. To deal with fallacies of distributed computing, it's going to be more complex. So which one do you want to pick? Well, let's think of the other part of our problem. Constant database changes. We've got to move very fast when we make those. Does anything kind of come out? And I'll give you a hint. It's right at the top there. What if we had a modular monolith, which everybody likes to do? Where's the database logic? Everywhere, because it's domain partitioned. In a modular monolith, we partition that application by domains, and each domain has database logic. So what does that mean? If I change the database, what am I changing in my architecture? Everything. What does a layered architecture do? It's technically partitioned. It treats partitioning by the use of that particular artifact. So consequently, this is a perfect use case for the layered architecture. And let me explain why. And because with the layered architecture, well, first thing, foremost is I've got a separation of concerns. I've got a persistence layer. It's a whole section of this architecture. Also, I've got great layers of isolation and good change control. Because here's the point. When I change the database, if this is done well, what do I have to change in the architecture? Just the persistence layer. That's fast. Well, what about everything else? Nope. Separation concerns, layers of isolation. Hey, you know what I just did? I just did a proof that the layered architecture is still viable. I mean, this is great, but what has to happen for this to occur? Presentation, business, and services layer cannot connect to the database directly. Because if it does, I got to change everything. Also, we have to respect these open and closed layers. Closed layers mean that I'm doing the request, I have to go through the next layer below me. I can't hop over it. But if the layer's open, I can hop right over it. Meaning the business does not have to go through services to get to persistence. Business can go straight to persistence. That's okay. So therefore, I opened the service layer. Yeah, you can hop over that one. Cool. But the other thing is that all database logic has to be in the persistence layer. I think we can all agree, yeah, you got to do this. But what happens? Development team, seeing this layered architecture, says, yeah, you know what? I just need the customer name. I'm not going to go through every single layer. I'm just going to call the database directly. So they do. The back-end team says, this is nonsense. I've got business logic here, database logic here, and I have to keep two places. You know what? That's dumb. I'm just going to combine those. Makes it easier to maintain. And that's the way they code it. And what do you suppose happens after production? I think we can all guess we're going to see my favorite animation, because now when that database change occurred, which, by the way, was the first week into release, we had to change every single solitary layer. Why? Because my architectural constraints weren't followed. There we go. Yet another fire. There it is. Okay, I promise. I think that's the last fire. Yes. I can make more. So how do we fix this problem? I mean, this, what I just described, everybody, is a real, actual problem. This is real. I didn't make this up. How do we enforce this stuff as an architect? I mean, walk around looking at your code all the time? I don't have time for that. Besides, you'd be really annoyed. Architecture as code. So let's take a look, because we can use all of these tools for these constraints. Now it's interesting. The prior examples I showed you were pretty trivial. Yeah, define domains, define subdomains, define components, define the interactions. Yeah, that was pretty easy. How do we do this? Ooh, now I've got you intrigued. I could probably spend an hour working in ArcUnit or ArcUnit.net to try to figure this out, or I can spend about a minute and a half writing an ADL and then just genning it. So, open and close layers must be respected. How do I do this? Well, here's my architecture has a description to it. This defines my structure. So here, define layer dependencies. So here's my system. Define layer presentation layer as presentation, define business layer, define services layer, and persistence layer. There's my layers. Assert that presentation has no dependency on services or persistence. What does that mean? Any code that's sitting in presentation can't invoke any classes anywhere else except business. Yeah, you can't hop over that. There we go. That's an ADL. As a matter of fact, put it into ChatGPT. There we go. That code ran immediately. Yeah, this is so cool. No classes that reside in a package presentation should access classes that reside in services or persistence. Here's the corresponding C# version of that in ArcUnit.net. Same thing. Classes and presentations should have no dependency on services and persistence. But boom, if you as a developer try instantiating anything in any of those other layers, which represented by packages or namespaces or directories, nope. That's cool. All right, that one was easy. How do you do this one? How would you write a test in ArcUnit or ArcUnit.net or PyTestArc to say that presentation, business, and services can't talk to the database directly? Or, as a matter of fact, we can combine these together. The only place database logic should occur is in the persistence. Check this out. All right. Restrict database access. Here we go. So, you ready? I can write an ADL for this. How am I going to instruct my developers not to do this? Oh, well, here's my system. Here's my 3 domains or layers: presentation, business, services, and persistence. You ready for this? This is the power of an ADL. Check this out. Read that assertion right there. Persistence layer is the only layer that contains database logic. Isn't that what we want to enforce? Yeah. I don't need more structure to that. That's my assertion. I've structurally defined all my layers. But now I'm saying this layer in persistence is the only one out of all 4 of those that can contain database logic. You want to see something really cool? Check this out. What do you suppose ChatGPT does with this? This is just so cool. All right, here it is. Here's my rule. As a matter of fact, classes outside of persistence should not depend on Java SQL connection, Java SQL statement, Java SQL prepared statement, Java SQL result set. There we go. It actually interpreted what I meant by database logic in Java and took all 4 of the primary Java.SQL classes and said, classes can't depend on any of those unless it's persistence. If you instantiate a statement object or a connection object or a result set, nope, because that's database logic. If I change a column, if I drop a table, I'm going to break your code. That is so cool. As a matter of fact, here's C#. It did the same thing. Now, in this case, it was a little bit easier. I mean, it's system.data and all the IDB command and IDB connection stuff for that. That's really neat stuff. This is what we have available right now to us. And as a matter of fact, these constraints can get easily misaligned, as I just demonstrated. And now, using these simple techniques realigns all of these things together. This is pretty cool stuff. So I'm going to make sure that you have all of these slides. And as a matter of fact, I want to close with this quote, which is my favorite quote in our book, The Fundamentals of Software Architecture. About to lose my voice here. Okay, let me do this. This is my favorite quote, and the book is like 550 pages. Developers should never take components designed by architects as the last word. Rather, the initial design that we architects create should be viewed as a first draft. Are you ready? Where implementation reveals more details and refinements. My favorite quote, favorite part of that entire book. I love this quote because what it really means that we as architects have absolutely positively no clue what that architecture will look like when this is released, or when this feature is developed, or when we add this new capability to our system or product. We go mobile. I have no idea. It's implementation where we find the problems and enhancements to the architecture. And that requires an architect to continually be involved in the development and ongoing life cycle of this system. The stuff you saw here today, we can use as a vehicle, a tool to be able to help bridge that alignment even with architects and development teams. And we're accomplishing a lot with this simple concept of architecture as code. So here's what I'd like to do. You know my website, developer2architect.com. So what I'm going to do is I'm going to make all these slides available as well as an ADL reference for all of you. So you can get the slides. Go to my website, developer2architect.com/downloads. Okay, that's easy because you're downloading it. So /downloads. And I'm going to make this very simple because I have to remember it. Watch me go home and go, wait, what was that URL again that I was supposed to upload? I'm going to name it, and I'm just writing this down so I remember it. I'm going to call this something simple. IMPL, IMPL, because it's implementation. It's the intersection of architecture and implementation. IMPL, IMPL dot PDF, okay? PDF, and that's for all of you. So there we go. So developer2architect.com/downloads with an S, plural, IMPL, IMPL for implementation, .PDF. And so give me, I'll have it done by the end of today. So I'll have those uploaded along with that Neil and I's ADL documentation. So you can kind of see what we created. Try it out. Try this out on some area. Just start with domains. That's probably the best place to start. At least we have domain partitioning within our system. That would be a really nice thing. Start with that. Modify the ADL as you see fit. This is not anything that's published. This is just something we came up with. Leverage whatever, Copilot, whatever you happen to be using to actually generate the source code and then execute it. See what happens. This is all stuff you can actually do when you get back to work next. So anyways, fantastic. I hope that you found that both enlightening and gained a better understanding of this whole thing of what is architecture. So I saw many aspects of it. This is yet another. So anyways, thank you all so much.